Moving on to the topic of discrete probability distributions. Let's start with an example. You decide to toss 2 coins. What are the possible outcomes that you could see? Well, thinking about this, if I toss 2 coins, I could get a heads and a heads. I could get a heads and then a tails. I could get a tails and then a heads, or I could get a tails and then a tails. Those are the possible outcomes. So this is my sample space of possible outcomes. So with probability distributions, we're going to be introduced to something called random variables. Random variables are variables whose possible values are the numerical outcomes of a random phenomenon. Random variables are usually denoted as X. So instead of thinking about the outcomes in terms of heads, 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 tails, tails, heads, tails, tails, we're going to be thinking about the outcomes in terms of how many heads did I see, or how many tails could I see? And that random variable is going to be denoted as X. A discrete probability distribution is a way to list out this random variable with the numerical outcomes of the random variable with its probability. In order for a discrete probability distribution to be valid, the probabilities must sum to 1. So what this means is we are going to have a column with our discrete random variable and its probabilities. If we list out all of our possible outcomes and all of our probabilities, and the probabilities don't sum to 1, then whatever it is that we think we're looking at, it's not a valid probability distribution. So let's expand on this first example and apply it to this new random variable discrete probability distribution idea. So let's call X, which is the random variable, the number of heads that you can get when you toss 2 coins. Create a discrete probability distribution showing each possible value of X and its probability. So we're going to set up a table. The first column of the table is going to be our random variable X, and X is going to represent the number of heads when you toss 2 coins. And then the second column is going to be the probability of X. So the probability that you see that many heads. So if I scroll back up and I look at my sample space, here I have 2 heads. Here I have 1 head. Here, oh gosh, what happened? I'm so sorry. I don't know what happened. Here I have 1 head. And here I have 0 heads. So my possible outcomes, the numerical outcomes for the number of heads are 0, 1, and 2. I could get 0 heads, I could get 1 head, or I could get 2 heads. So that's what I'm going to list under X. I could have 0 heads, that's where I got 2 tails. I could get 1 heads, or I could get 2 heads. Now I want to find the probability of that. So again, I'm going to come back up here. I had 4 possible outcomes in my sample space, and one of those 4 outcomes resulted in 0 heads. So the probability of 0 heads was 1 out of 4, 0.25. The probability of 1 heads, there was 2 of those, these 2 right here. So that's 2 out of 4, or 0.5. And then the probability of 2 heads was 1 out of 4, or 0.25. And I can check real quick. Does 0.25 plus 0.5 plus 0.25, does that equal 1? It does. So I have a valid distribution. That means I'm not missing any x's, I'm not missing any probabilities. We're good to go. And this is really good because now that I have x values and I have probabilities and my x values are in terms of numbers, there's a lot more that we can do with that now. So this is an introduction into random variables and discrete probability distributions. We're going to be using this sort of terminology and fun stuff for a while.